Hello, and welcome to polyplane.com. In this pre-flight video, we're going to be talking about object transposition. Object transposition for our purposes is just going to mean to move an object around in space, reorienting it in a different way. This is critical for every bit of geometry that you're going to touch, whether you need to touch a point, a line or curve, a solid, a mesh. Doesn't matter. You're probably going to have to move it around to get it to look the way you want it to look. This sort of transposition breaks down into 4 different families: move, scale, rotate, and reflect, or mirror. The first type of transposition that we'll be talking about today is called translation, or moving an object. The object can move in 3 different ways. It can move on the x-axis, the y-axis, and the z-axis. This can be done numerically, like you type in an amount, such as you want to move something 1 inch to the right, and you specify a point, say the bottom left corner, and you use that point as your reference point, and you type the number 1. It's going to move your object 1 inch. You can also do this arbitrarily, where you select the object and then move it around the screen until it gets into the position that you want it to be in. In this example, I'd like to move around this bicycle. I'd like to move it about 3 inches to its right, so +3 on the y-axis. So I select the bike and type move, and it's asking me for a reference point. So I'll say down here on the tire, and then I'll type the number 3. So as you can see, it's now locked to 3 inches in any direction off of that given reference point that I initially typed in. If I hold down shift, I can control the angle that it moves to a snap, so it's snapped at 90 on the Y. Now I click and it's moved over the 3 inches. If I'd like to move it up in space or on the Z-axis, I'll come over to my right view here and type move again. And for this sort of thing, it doesn't really matter where you click as your reference point, because it's just giving it a place to say, okay, move this from where to where. So I'll say here and move it 3 inches on the Z-axis up. So now I've got a little bit of space there. That's the numeric way to move around an object in space. To arbitrarily move this around in space, I can just grab the bike and just start pulling it around, and it'll go where I want it to go. Rotation is often considered a cousin of the move or translate tool, because you're still you're moving the object around in space, but you're pivoting it on an axis. So it can turn in any axis, but typically you're going to move on the X, the Y, or the Z axis. But just like the move, you can do this numerically by typing in specific angles, or you can do it arbitrarily. It really depends on the circumstance. So in this case again, we can take the bicycle, type rotate, and now it's going to ask me for a center of rotation. So I'm going to pick around the middle of the bike at the bottom, and I want to rotate it 90 degrees. Now the bike has been rotated. I can also do this action arbitrarily as well by just clicking wherever, and now you can see it's gonna pivot around that point. I don't necessarily have to select the whole object. Maybe there's just one detail that I want to change on here, such as this pedal. Well, I can just select the pedal, type rotate again, and it'll follow the same prompt. It'll ask me where I'm rotating from, and then it's asking for an angle. So we'll just flip that up like so. And as you can see in the perspective view, that's now changed. The move and rotate tools are really good for moving your object around in space to orient it in certain ways. But what if you want to kind of change the proportions on the fly to kind of just check things out, or maybe you want things to snap or fit into a different way? That's where the scale tool comes in. Now the scale tool is a little more complicated than the other two, but it's still very useful and very easy to learn. In Photoshop and Illustrator, you're used to stretching and squishing and manipulating objects to get them to fit the way you want to. This is really no different in 3D space. You're just dealing with one more axis. So I have 3 different examples here. The one on the left is scale 1D. That means that I'm only scaling my object in 1 dimension. So it could be I'm scaling it in the Y, I'm scaling it in the X, or I'm scaling it in the Z. If I were to do this to this rectangle down here, if I wanted to scale this on the Y, I would just grab the top handle here and pull it up. Or on the X, I would just pull on this handle and get my shape where I want it to be. In Rhino, the scale 1D is very similar. You have to keep in mind when you change your geometry in an X and Y, it doesn't mean that the Z is going to change too. So if I type in scale 1D, it's going to ask me for an origin point. So we'll say down here at the bottom tire. And I'll click about here and just start pulling it up. And as the view suggests, the form's going to start to get a little wacky. And if I come into the perspective view, you can see it's only really stretched up in one view. Kind of looks pretty neat. And again, I can come back in and do this operation again in the opposite direction and really start to stretch it out even more. Remember, when you're actively affecting one viewport, your other two viewports aren't being affected by that, so the bike's going to stay pretty skinny. The next scale operation, scale 2D, is as it sounds. You're scaling in 2 dimensions at the same time. So if I grab from the corner handle on this square, I'm both working the X and the Y axis to get the shape that I want. This is a little more efficient. But sometimes you only need to use the scale 1D, but it's still not activating in 3 dimensions. For this example, I'm going to maximize the front viewport and type scale 2D. It's asking me for the objects to scale, so we'll select our bike, hit enter. And now it's asking for an origin point again, so we'll type 0 this time. And it's asking me for a scale factor, so I'll do it kind of big and zoom out. Now it looks like the bike is completely scaled up, but if you keep in mind that you're only working in 2 dimensions here, so when you look at the bike from that 3rd dimension, it's actually really, really skinny, and you've drastically affected the proportions of the bike because you're only working in those 2 dimensions. So if I undo, and we'll try it from the top view, you can see that right view is actually getting really, really wide. And that's because it's not being affected on that axis. So these first two, they give you a really good way to explore your form, proportions, and that sort of thing. Or maybe you just need to adjust some measurements, or maybe some metric changed somewhere and you need to change stuff up on the fly. Scaling is a really good way to do it. Our third option is to scale in 3D, or you can just type scale, and Rhino will assume you just mean 3D. This affects all 3 axes at the same time. So let me show you what that looks like. If I type scale, it's going to ask me what to scale. I'll select everything. And now it's looking for an origin point. So I'll go bottom front tire again and start scaling up. And this is how you can scale something up uniformly in all 3 dimensions at once, is just typing scale. And it'll change your model appropriately, and everything will stay in the same proportions without any sort of warping or funkiness. Finally, the last object transposition that I'd like to talk about is called mirror, or some programs call this reflect. So essentially you're making a copy of whatever your object is, only you're flipping all the numerical values so that everything is reversed. This can be done numerically or arbitrarily. I typically do this numerically. Looking at our bike from the top view, I'm going to go ahead and type mirror and select my object and hit enter. Now it's asking me for the start of the mirror plane. So I'm going to do it right about there and copy it over. And then I'm going to make another copy from here over to there. So now we've got 2 copies of the bike, one on the y-axis and one on the x-axis, 2 different mirrors. What if I arbitrarily wanted to mirror this bike on say a 45-degree angle? I could type mirror, and we'll mirror it from here to like something about there. And you can see the bike has now been mirrored on a 45-degree angle. This can be really particularly handy if you're trying to do symmetrical products that you only want to model one half of it, and then you flip it over and your other half is already done. It's probably one of the more used tools that you'll use in any 3D modeling program. So those are the basic object transpositions that you'll be using from day to day in Rhino. And they're actually very useful. So just really quickly, up here at the top is move. Its cousin is rotate. Across from that are the scale triplets, scale 1D, scale 2D, and scale 3D. Remember, scale 3D is just scale. That's all you have to type. And then mirror, or reflect as it's known sometimes. I hope you found this useful. Thanks for watching and have a great day.